Hello friends, welcome to EPG Pathshala. After learning standard C++ input-output operations and how to format them, let us now see how to do input-output operations from files. So, we will see today now the use of files to perform input-output operations. Once we have learned standard streams, it is very easy to learn even file streams, because the file streams are inherited from the standard streams classes, and therefore, all the functions, all the data members and everything is available to these classes also. The syntax for read write or extraction, insertion, get, put, everything is same as standard streams. So, let us see now in detail how to work with files. In today's module, we will discuss about what do we mean by file, what is the need of file, how the file stream classes are derived from standard stream classes, what operations we can perform on files, how can we access the files, that means sequentially and randomly, and different file types like text files and binary files. We have already seen text IO and binary IO with standard streams. The same applies here also with files. What is file? File is actually a physical file which is stored on auxiliary storage devices, secondary storage devices like hard disk, CD, maybe pen drive, and so on and so forth. The basic difference between standard IO streams and file streams is, in standard IO streams the data is stored in memory. So, sometimes we say as in memory streams, whereas in case of files the data is stored in permanent files. Unless and until we delete, the data will remain there. That means the data storage is persistent and not transient, and each file ends with end of file marker. In C++, the file is viewed just as a sequence of bytes. What is the need of using file? As I said, when we perform standard IO using in memory, the data is transient. That means as soon as the program terminates or as soon as the power goes off, the data from the main memory will get lost. It will not be available for next use. If we want the data for next use, then it should be stored in persistent storage devices. So, here let me say we will use files for storing such data, especially when the data is very large in amount. In that case, it will be very difficult to input the data from keyboard type of devices. It is better we should store the data, create the data in files and use it. For example, if I want to have the matrix multiplication and I want to input the data from keyboard, suppose my matrix is of 10 by 10, it will be very difficult to enter 100 elements through keyboard. It is better I store all those 100 elements in the file and then use the file to read the data for the matrix. Another requirement of the file is whenever the data is to be accessed or modified by other programs, especially in most of the business applications, the master data is usually stored in the files and which is used whenever some transactions occurs. For example, in banking application, the account details of the persons will be stored, and whenever the person comes for deposit or withdrawal transactions, the balance amount needs to be modified or updated. In such cases, the existing balance should be available across all the programs, not necessarily only one single program is getting executed. Similarly, in railway reservation system, the need is to store the details about the trains, the schedules, the fare, etc., because that is to be used by many programs and not just by single program. So, in such cases, the use of file is must. In C++, to use the files, we require the file classes and the library to be included. We need to include IStream and FStream library to use the files. The classes are IStream class, which is derived from IStream class, OStream class, OFStream class, which is derived from OStream class, and FStream class, which is derived from, which is multiply inherited from both input as well output, that means IStream and OFStream. Now, once we have these classes, it additionally uses one more class which is file buff, just like stream buff for standard IO, where the buffer will be allocated to control the transferring of data between the associated files and the memory. And the file operations, we will see the basic file operations like open, input, close and read write. As I said, it is very easy to work with files because the file classes are inherited from IStream classes and it uses the same library, and therefore, the syntax of using all the functions, even checking the error remains same. The only thing is in files there are some additional functions and data members which is required to be used, but almost 90% of the task can be done the same way as we have done with standard IO streams. So, the basic difference between standard stream and file stream is when we use standard stream C in and C out. C in and C out are the objects of IStream and OStream class respectively, and they are predefined in the global namespace STD. So, they are available to all the programs. The programmer need not create those two objects or instances, whereas in case of files, the programmer required to create the file instance, the object of the type either IFstream or OFstream or FStream. Once the instance is created, it requires to get connected to the physical file which is already residing on some secondary storage devices, and at the end it requires to close the file also. Whereas these three tasks, creating the instance, associating with the physical file and closing or destroying the object, these things are not required with the standard streams. Another difference is with the access type. With standard streams, we actually use those streams for sequential access. We can use them for random access, but it is meaningless. It does not make much sense for the random access. When I say random access, access from anywhere, from any point you can read or write the data. Whereas in file, the sequential as well as random access are meaningful. So, let us see now basic file operations. The basic file operations include creating the file stream, opening the file, that means connecting the file stream to the physical file, processing the file. During the process we will read the data from the file, write the data into the file. We can check the input output errors when the input output operations takes place, and in the last we will close the file. The processing of the file, all the operations are very similar to using the operations with standard streams. So, let us see first of all creating the file stream object. To define the file stream object, we can use two constructors, either parameterized or non-parameterized. Using non-parameterized constructor requires the file stream class name and the name of the object, that is all. For example, I say IFstream INP file. So, INP file is the object of the class IFstream, OFstream out file is the object of the class OFstream, and so on and so forth. When we create the instance of IFstream class, by default it is used for only reading the data. So, just like cin. When we create the object of OFstream class, it is used for writing the data, very similar to cout. And when we create the object of FStream class, it can be used both for reading as well as writing. Using parameterized constructor. When we use the parameterized constructor, we can do two tasks together. One is creating the instance itself of the type for the file, and another is connecting the stream to the physical file. Both the things are done together. And here the parameters which we are passing is the name of the file, the mode to open the file, and additionally the access mode. So, for example, IFstream INP file, name of the file is data.txt and it is opened for input. Of course, as I said, whenever we say IFstream, by default it is for input itself, but this is how two parameters can be passed. We will see in detail opening the file and connecting the file stream to the file. Now, as we have said in the previous slide, we have shown that we can use two parameter or three parameter constructor to create the file instance or file stream also, and to connect it to the physical file. So, in the single statement we are doing both the task, creating the instance of the object for the file and connecting it. We can also use OpenMember function, but when we use the OpenMember function to connect the file stream object must have been created in advance, and therefore it requires first of all creating the instance and then connecting it to the file stream. So, here we are using the function open, object.open. File open mode. Now, there are various modes in which file can be opened for different operations. For example, in for input, out for output, APP for appending the data, that means only output, but we are appending the data at the end, ATE, trunc, binary for binary IO, no create and no replace. We will see these flags in detail Now, all these flags are defined in the iOS base class with the bitmask type open mode, but because our iOS class is derived from iOS base, they are available to iOS class also. So, many times we use iOS : as the scope resolution operator. Open modes, the first one is in, which is the default one for IFStream. In this case, file must exist and we are using it for the reading purpose. Bit out, we are using it for writing purpose and it is the default for OFStream. In this case, if the file is existing, then it will override the existing constant from the beginning. If the file is not existing, then it will create the new file with the specified name. Mode ATE, at end. Here it positions the file pointer at the end, that means the starting is from the end, and it allows writing anywhere in the file at any point, whereas in case of APP, again the starting position is at the end, but it allows writing only at the end. The option trunc is used if we want to truncate the content of the existing file to 0 length. So, after opening the file, it will delete all the content. It is as good as deleting all the content and the file pointer will be at the beginning of the file, overwriting all the contents. Now, next open mode is no create. No create means it should not allow to create the new file. That means if the file does not exist, then it will return the error. It will not allow us to create the new file. No replace is not replacing the content. No overwriting is allowed. So, if the file is existing and suppose I have used ATE or APP, I have not used at end or APP, that means the pointer is not at the end, then it will start overwriting from the beginning, which is not permitted for output. Option binary is for binary input output where no conversion is taking place, as we have seen in standard stream binary operations. If we want to set multiple bits at a time, we can use bitwise OR and combine those flags. For example, if I say iOS in bar iOS out, that means I am opening the file for reading as well as writing both the purpose. Default file open mode, if it is the object of IFStream class, then the default is in, that means for reading only. If it is OFStream class, then the default is out and truncate. That means the file will be used only for output, and if at all the content is there in the file, then it will be truncated first and then it will start writing in the file. For FStream, the default is in, out and trunc, all the 3 flags are set. So, it will be used for input as well as output and the content will be truncated. Unless and until we specify explicitly the binary open mode, the file will be considered as the text file. That means all the operations which we are performing will be text input output. Now, checking the input output error from the stream state is very similar to what we have done for standard streams. So, we can check good bit, bad bit, fail bit, end of file, we can use overloaded operator not, we can even check the RD state. So, all those things are very similar to checking the error for standard IO streams, because they are inherited, it applies to file stream also. Here just a simple example where you can use those functions for checking, you may try it yourself. Now, as I was saying, all the classes, all the data members, the function members of base classes are available here, and there might be something additional in files. So, here additionally you can see is open function member, which can be used to check whether the file is opened successfully or not, in addition to other ways as shown below, whether good, fail, bad bit. Suppose I say if file object, it returns a null if there is an error, otherwise not null, that means true. So, other things can be used equally as we have used it in standard streams. The only additional functionality which is available here is open function, which returns true if the open is successful. Once working with file is over, we should close the file. That means it is as good as destroying the file stream object. When we destroy the file stream object, it will flush the stream and release all the allocated memory for other use. Closing the file can be implicitly done when the program gets terminated or when the file stream object goes out of the scope. It will call implicitly to the destructor and close the file. Explicit closing can be done by using the CloseMember function, by invoking the CloseMember function of the class. Here when we close the file stream becomes empty, but it is not destructed. That means the file stream object is still available to connect it to some another physical file. Now, let us see other operations which are very similar to standard IO input output operations, using standard streams. Reading from text files. So, this is very similar to text IO using standard streams. Here cin. So, whatever functionality we have used with cin everything is available with files also. Whenever a file is opened for input, that means we can use the extraction operator greater than, we can use the member functions get and getLine, get without argument, get with one argument, getLine with 3 arguments, exactly the same way as we have used for getting the data from Cin. Similarly, writing in the text files again is very similar to working with IStream object. We can use insertion operator, we can use put function, put back, write is for binary. Here is the example of reading string from file. So, input file contains various words in the file, we are reading those words and we will reverse those words and write it in the another file. So, see how we have used the operators. The different things from standard stream is, first of all, we will have to create the instance and connect it. So, that is done here with the statement IFstream fin, and the data file which is connected is data.txt. I have not used open mode here. When it is not used, by default it is depending upon from which class I have created the object. Because it is of the class IFstream, the open mode is input by default. After that, we check whether the file is opened successfully or not. Here I have used the function is open. If file is opened successfully, we will proceed ahead, otherwise we will exit with the displaying of the error. Similarly, another object is created for the output file. So, here it is of the type OFstream and we have used another method to connect it. So, first of all, we have created the instance and then we have connected it to the file named reverse.txt. Here also default mode out is used. The successful operation of open is checked by using overloaded not operator here. If not f out, that means the file is not opened successfully. And after that, we have used f in greater than str, very similar to c in greater than str for reading the data, for get input of the data, and we have used f out less than in a way similar to output of the data using less than operator. See the use of put also, f out dot put, in the same way as we used c out dot put. In the last, we require to close the file by using explicit calls to close function. So, we have used fin.close and fout.close. Once we have seen the standard IO operations and file operations, very similar to standard IO. Next is formatting of the data. Formatting of the data is also done exactly in the same way as we did with standard IO streams Cin and Cout. We have used 3 format variables, width, fill character and precision, and we have used one format flag with many bits for format setting like horizontal alignment, specifying the scientific or fixed decimal point, showing the point, showing the base and so on and so forth. We can use the manipulators, we can use the function members exactly in the same way we have done with standard streams. So, we will not discuss much about that. The only thing is we are using the file streams here instead of standard streams. Now, what are the problems with sequential files? Whenever we read or write the file sequentially, I cannot have random access. That means, if I want to go directly to the 8th record, I cannot go to the 8th record unless and until I have read first 7 records in the sequence. Now, this type of access will not be appropriate whenever we want faster access. For example, I have to update the marks of student number 8. I may go directly to the 8th record and update the marks of 8th student instead of reading unnecessarily first 7 records. So, I can save the time. So, this way it will provide faster access. So, wherever quick access is required, we should go for random access. For random access, we need to have some methods to set the position, from which position I want to read the record or at which position I want to write the record. And for that, with file streams or even with standard streams, actually all the streams, whether it is standard stream or file stream, they contain 2 pointers, get pointer and put pointer. Get pointer is available for IStream, that means for reading, and put pointer is available for OStream, that is for writing, for next write, and get is for next read. We can use the member functions to know the file position and to set even the file pointer in the position. So, here the functions which we will be using is seekg, tellg for IStream and SeekP, tellp for OStream. Seek is used to set the file pointer and get is used to return the position of the file pointer. For IStream class, when we say tellg, it will return the current position in the file, and when we say seekg, we will have to, with seek function, we will have to pass two parameters, the offset, and that offset is to be considered from which relative position, whether from the beginning of the file, from the end of the file, or from the current pointer in the file. Whereas with tel function, no parameters are required because it is simply returning the current position in the file stream. So, the first parameter in seek is the offset. It can take even negative value because sometimes we may want to move in the backward direction also. The default value is 0. Whereas the relative position is defined as ios : seek dir, which is of the enum type in the base class, and it can take the values. The three constants are ios : beg for beginning of the file, cur is for the current position, and end is for end of file, end. By default, the value is considered as a beginning of the file, that is ios : beg. Let us see some examples. For IStream object, suppose INP file is of the type IStream. As I said, it may be a file, it may be even my standard input cin. So, any stream we will consider. These functions also apply to standard IO streams, not only to file streams. But as I said, with standard IO, it is not making any sense. So, let us consider INP file as the member of IFstream, is the object of IFstream class. Then if I say INP file dot seekg with no parameters, it will use the default values. By default, the initial location offset is 0 and the relative position is beginning of the file. That means it will place the pointer to the beginning of the file. If I say seekg n ios beg, that means it will move my file pointer to n positions from the beginning to the right of the file in the forward direction, because here it is, we should use n as the positive value for forward direction. If I say from end n bytes, of course I should go for backward direction, that means I should use n as the negative value. If I want n bytes either in backward direction or in forward direction from current position, I can use INP file dot seekg n ios cur. Depending upon whether n is positive or negative, it will move my file pointer in forward or backward direction. In the same way, we can use SeekP for the output stream, for setting the file pointer in the output stream. To get the file pointer, we can use telg and telp. Let us see the use of seek and tel functions. Suppose I want to find the size of file in bytes. I can open the file, I can use the telg to get the beginning of the file. I can move my pointer to the end of file by using seekg 0 ios : end. Again I get the file pointer using telg, and this difference of the beginning and ending I can use to get the file size. Another option is I can open the file by putting the pointer at the end of the file and simply say telg. So, these are the ways I can use, or we can use seek functions and tel functions. Now, whenever we want to do the updations, especially updating the sequential files is not that easy, because it will involve the risk of getting the data lost by overwriting. For example, I have the old data JYOT space GLS, and I want to have the new data as JYOTIKA space GUJARAT space LAW space SOCIETY. In that case, when I am trying to write the data at the same place, the modified data, if after GLS in the old data, suppose it is end of file, even end of file marker will get lost, and if at all I have some other data, that data also will get lost. So, it is not advisable to do the updations in the same file. Instead, we should go for writing the updated data into another file, maybe sequential file. Or the best alternative is to use the data with fixed length records and updating. Now, let us see binary files. Binary files used for binary IO, that means raw data is written without any conversion, no conversion takes place. If we want to have binary input output in the files, we should use file open mode ios : binary while opening the file or while connecting the file. The advantages of using binary files mainly are, it is not that easy to modify the data in the binary file through text editors. So, in a way it will provide the data protection up to some extent. And another advantage is the faster operations because it does not require any conversions from binary to text or text to binary. Whatever data is provided, the same data goes in the between stream and memory without taking any conversion. To read and write in binary files again is very similar to read and write using standard I/O. So, we will be using read function and write functions as we have used with cin and cout object respectively. When we want to read the number of bytes from specified stream, the syntax is the stream object dot read, and we need to pass the character pointer and the size, how many bytes we want to read. Similarly, in write, how many bytes we want to write. For example, fin dot read char star ampersand s and size of s, where s is the starting address of the buffer where the data is to be input. The same way we can use write. We will provide the starting address of the buffer from where the data is to be written and how many bytes are to be written in the size. In binary files also we can write at random position. Suppose I have the student data class and student is the object, for example. Now, I have created one FStream object, say fout, which is opened in binary mode. Now, I want to write the data directly at 10th position, for example. Then I will have to skip first of all the size of 9 previous records may or may not be existing. In that case, I will have to use fout.seekP n-1 into the size of the record, the student data here. That means, those many bytes I am skipping from the beginning of the file, and then at the current position I will be writing using fout.write. We will provide the character pointer to the starting address of the student data, student object, and the size of the student class. So, it is very easy, just like binary write operation in standard stream using cout. Similarly, we can even do binary read from the file using read function, which is very similar to what we have used in our previous modules cin.read. That is all. So, in today's session we have learnt about working with files, how we can do input output operations using files. With files, all the operations which are performed are very similar to the operations with standard stream cin and cout, because the file stream classes are inherited from IStream classes. So, all the functionality, all the data members, everything is available in these classes also. The only difference is that standard I/O operations were done in memory. So, whenever the power goes off or as soon as the program terminates, those data were getting lost. It was just the transient memory, whereas here we want the persistent storage. So, whenever we want persistent storage, especially whenever we want to process large input of the data, or whenever we want to have the data available across many programs, in that case we need to use files. With standard streams that is not possible because we require persistent data storage. Files provides persistent data storage. So, only additional operations which we have learnt other than the operations with standard input output streams are creating the instance of the file, connecting the file stream to the physical file, destroying the file stream object, and isOpen function to check whether the file is opened successfully or not. Otherwise, everything was same as standard input output.